my pleasure to introduce Mr. Amod Ranade, who currently holds the position of Vice President and General Manager, Asia Pacific at GRC, the Immersion Cooling Authority. With over a decade of professional experience, Mr. Ranade has an impressive track record in various leadership roles. Previously, he served as Director of Engineering at Honeywell, where he managed diverse portfolios and played a pivotal role in strategic marketing initiatives. During his tenure as General Manager of Strategy and Transformation for Schneider's operations in India, Mr. Ranade focused on assessing and collaborating with startups in building automation, energy management, and IoT. Furthermore, as General Manager of Data Center Business Development, Mr. Ranade drove the data center solution business. His background in engineering is complemented by MBA in marketing, making him a well-rounded professional with a strong foundation in both technical and strategic aspects of the industry. Today, Mr. Amod will briefly overview us about the liquid immersion cooling enabling sustainable data centers. Please join me in welcoming Mr. Ranade.
I would like to take you through an approach which to some extent helps mitigate the challenges with respect to corrosion, but also something which is the future of data center cooling. So let me begin by introducing you to GRC. GRC is a company based out of Texas, USA, and we were founded in the year 2009. So contrary to belief, liquid immersion cooling, and in particular single-phase liquid immersion cooling, which is what GRC provides, is not really that new. Although we are seeing a lot of interest and adoption increasing now, but the technology has been in play since the last 14 years. In the last 14 years, we have been able to have a presence of our solutions in over 21 countries all over the world, with a capacity exceeding 18 megawatts. Large projects which are with respect to national defense, high performance computing, supercomputing, trading, simulations, cloud deliveries, AI. These are the kind of application areas where we already have a considerable install base all over the world. One of the key factors which differentiates single-phase liquid immersion cooling is the overall efficiency that it can deliver for a data center customer. And so we are seeing partial PUEs, which is the HVAC PUE of close to 1.03 for the system. Total PUEs of data centers, we have already delivered close to 1.1. And this 1.1 is also deliverable in a tropical environment like India. So we are no longer talking about technologies which are not suitable for our tropical climates. So we are talking about a technology which is very applicable to the tropical climates like India, and we are able to drive extreme efficiencies from the overall infrastructure from an energy consumption perspective. Right from the inception of GRC, our mission has been very simple. We would want to help our customers change the way they design data centers, they build data centers, and they operate data centers. Overall, making them more sustainable and efficient. As a result, single-phase liquid immersion cooling is something that GRC has invented and it promotes. Many of you will be thinking, we know that data centers have been cooled by air cooling for more than 50 years now. And we all know that it all works, right? So there is no challenge that, air cooling is not working and data centers are becoming too hot. That is not really what we hear around us in the industry. So then why is it that GRC and me today are talking about something different called as single-phase liquid immersion cooling? So to bring into view the challenge, which is already present in many applications, and it is only going to get more pronounced in the future, is indicated by these two graphs which you see on this slide. The graph on the blue side is a forecast which was given in the year 2009 going up to 2020, where the TDP or the thermal design power for a chip, meaning the power consumed by the chip when it is operating at the maximum allowable temperature. That is how the chips are designed, right? So we were seeing that from something close to 120, 130 watts, we were estimating that there would be chips available by 2020, which would be more in the 400 watt range, meaning 3 times increase in power consumption. Now look at it, the slide on the right hand side. This is something which I took from Google. I am also giving you the source where I've taken it from. Here it is being shown that by the year 2025, it will not be very strange to have chips where a consumption is 1000 watts per chip. So from 130 watts in 2009 to 1000 watts in 2025 is a huge jump, right? Almost 8 to 10 times jump in power consumption. Now the question that comes to the mind is, with this kind of an increase in density, are the current air cooling technologies going to be sufficient? If you ask any engineer, he will tell you there are only 3 variables to play with, correct? What is the air temperature, what is the flow of the air, and what is the size of the heat sink, right? And they will give you formulas. I actually tried it on Google. There are tools available which will help you decide this also, right, on your own. Now, what does that mean? Does that mean we can easily cool a 1000 watt chip? The answer is no. Because although theoretically possible, you start getting into a practical difficulty with respect to handling very high velocities of air, or the overall compromise of the size of the server, where you start making heat sinks which are 4 times, 5 times larger. So you are again going back to non-being sustainable, because you will consume more material from the earth in terms of either the heat sinks or the size of the servers which will go up, which means your density is going down. So the trade-off doesn't really work out. And that is where what we are seeing is, today customers have started wondering, how do I design a data center today? If what you are seeing already on the screen, which is a reality today, just to share with you, we were also part of the India Mobile Congress last month, and we demonstrated the latest Intel CPU, which is Sapphire Rapids, 650 watt power consumption, which is here shown for 2023. It is already here. So the probability that everything else which is on the slide also will be here by 2025 is pretty high, because the Moore's law is in action and chips are getting more and more compacted any day. A data center owner plans a data center infrastructure for 10 to 15 years in terms of a capex. So very easily, if you assume a 3 to 5 year life cycle of an IT equipment, at least 3 refreshes are given in a data center infrastructure which you are planning right now. And looking at these charts, it is very easy. Every identity refresh will practically double the power consumption of the CPU. And so customers have started wondering, what kind of a data center should I design today so that it is able to take 2 and 3 more refreshes of IT? And that is where air cooling is becoming a challenge. To add to the problem, earlier we used to see that most of the servers used to be CPU intensive. Today we are finding there are GPU intensive servers as well, where there are more GPUs than CPUs in a server. What is fueling this trend? Technologies like artificial intelligence, deep learning, machine learning. These are application areas where you need a very different kind of compute infrastructure, and hence they are GPU rich. And on the chart, if you see, it is the GPU which is expected to go up to 1000 watts in the near future. And so this becomes a serious challenge. So what is the solution? We need to create a data center infrastructure today which is easily be able to cater to the requirements of the future while being more efficient in doing so, right? And that is where the answer is not into increase the number of fans, reduce the temperature of the air. That is not an answer, because both these actions only increase the energy consumption and reduce the efficiency of the overall system. Now you would say that, okay, you are from GRC and you have a technology called single phase liquid immersion cooling. So it is very natural. You will say this is a very good technology, right? But the proof of the pudding is when the industry recognizes that, yes, this is the right step to go for. And that is the reason on this slide, what I'm showcasing are comments by Google, Microsoft, and Intel. All 3 of them are saying liquid immersion cooling is here to stay. And if there is any technology today which has a potential to mitigate the challenges of cooling and sustainability together, it is liquid immersion cooling. That is what these OEMs are saying. Why does it really work better? So if you look at the next slide, in a traditional air cooling environment, if I put a chip, a CPU, I provide air at 32 degrees Celsius, it will operate at close to 85 degrees Celsius. Now, when I use a different medium called as a single phase coolant or a liquid, I provide that medium at 34 degrees Celsius, 2 degrees higher. But we find that the chip temperature doesn't exceed 65 degrees Celsius. Now you will say, how is it this happens? This happens because the medium that we use is 1000 times more thermally conductive than air. I am sure many of us will remember our school days when we were told how sweaters keep us warm. It is because of the air pocket between the fibers. And so somewhere in the back of our mind, we all know that air is actually a bad conductor of heat. But because it is freely available and because the densities were not very high, we have been using air as a medium of cooling. But now that the temperatures are going to be higher on the chips, the chip power consumption is going to be 4 times, 5 times more, we need to find better mediums to capture that heat. And that is where single phase immersion comes into the. Now, when I have a solution where I can operate the chip at 20 degrees lower temperature, right? That is what we are showing. What are the benefits that you can draw? So there are very clearly 3 ways customer can benefit from it. First, he can say that, okay, the chip is designed to operate till 85-90 degree anyway. And because of the medium, it is still at 65. So speed up the chip, right? Overclock the chip. Get the chip to work more until it reaches that 85 degree temperature is one way of operating. What we are doing is getting more performance from the same chip. The second way to operate it is, okay, if I operate the chip at 65 degree itself instead of 85, I am providing lesser thermal stress on the chip, which means the performance would be better, the life of the chip would be better, and so it will require lesser maintenance. So the reliability of the IT infrastructure improves if I just continue to operate at a lower temperature. And the third is, if I really want to take benefit of efficiency, if I am operating at 65 degree or 85 degree from a chip temperature, if I can take the coolant higher temperature like 50 degrees Celsius, do I really need a refrigeration cycle? Becomes a question. Today when we do air conditioning, the ambient temperature is higher than the temperature you want to maintain inside, and hence you need a refrigeration cycle. You need a refrigerant, you need a compressor, etc. If I am able to get a coolant at 50 degrees Celsius, and your ambient temperature in summer is, let's say, 45 degrees Celsius, I am hotter than the ambient, which means I can reject heat without a compressor. And that is the secret behind liquid immersion cooling, where I talked about PUE of 1.1. Because effectively speaking, depending on the density of the racks, we can effectively provide a solution where you don't need a refrigerant cycle at all. It is simple dry coolers, just some pumps and fans which are operating and helping get rid of the. How does it work? Conceptually, it's a very simple idea. We take a tank, which is nothing but a horizontal rack. We fill it up with the coolant and we insert the servers inside that. Now, because I am not depending on air, all these servers, we remove the fans. The moment I remove the fans, 15 to 20% power consumption is removed, because in a typical server, 15 to 20% is the power consumption in the fans of the server. So the customer starts seeing the benefit of energy efficiency even before we start the data center, right? All the fans are removed. Now I need to move this coolant so that it is effectively capturing the heat. And that is where we use a coolant distribution unit with a pump. So the heat gets captured by this coolant, which is 1000 times more thermally conductive as compared to air. Now to reject this out, we transfer this heat to a water loop using a plate heat exchanger. And so we can use, depending on the solution, the outdoor climate, the region, the density that you are working on, either we can use a chiller at a high temperature, or we can use cooling towers, or we can use dry coolers, or we can use adiabatic dry coolers to reject the heat into the environment. So this is how the solution simply works. What is the benefit of it? The benefit is a sustainable solution which helps the customer take care of higher density IT equipment, more power consuming CPUs, but operating with an efficiency which is much larger, much higher than what traditional air cooling can provide. So effectively speaking, for our tropical climate, a best-in-class PUE is 1.6. What it means is, if you have a 1 megawatt data center, its power consumption will be 1.6 megawatts. Comparatively, if I design a liquid immersion cooling data center I can get you a PUE of 1.1, which means for the same 1 megawatt data center, I will actually consume 1.1 megawatts. Now bring into the picture the fact that 15% energy is already reduced because of the fan removal. So that 1 megawatt actually becomes a 150 kilowatt data center. So your overall data center consumption reduces by almost 50%, 600 to 650 kilowatt is reduced. And so there are tremendous opportunities to save in terms of energy, which adds to the company's sustainability goals. What is the way forward? Very clearly, anybody who is planning a new data center today needs to take into the fact that yes, the chip densities are only going to increase. They need to start realizing that there are technologies available today in India where you can achieve PUEs very close to 1.1 and cool high density equipments. What do I mean by high density? 2 kilowatt rack is what we can really cool with our technology. Today, you will not find IT equipment available which can create 92 kilowatts in a rack. But when you are building a data center today, where in the next refresh cycle or the refresh cycle after that, very clearly we see the possibility of having high density racks which are close to 90-100 kilowatts. This technology will be able to sustain the life of your data center. So there is a comprehensive portfolio. We have comprehensive partnerships across the ecosystem, be it IT OEMs, coolant manufacturers, system integration partners. So there is a huge ecosystem that we are a part of, which helps customers deploy liquid immersion cooling to get the three benefits: efficiency with respect to power consumption, flexibility with respect to location, footprint, space saving, and enhance sustainability by reducing the overall carbon footprint of your infrastructure, reducing the water usage in your infrastructure, and giving you the need to actually think about reuse or repurpose of rejected heat and create a more sustainable environment for our future generations. Thank you.